Hello and welcome. Harder indefinite integration. This is an integral which is of a similar type to what I've shown you a few integrals ago. It's kind of like logs, lots of logs, or log of x. Actually, that shouldn't really be the log of x. It should be log of x squared or something. Let me just find it to just double check it. Yes, it is. So this should be the log of x all squared. Okay, lots of logs. Well, it's definitely some kind of integration by parts. Pardon me. These integrals are easy to make, and I've done quite a disgusting version of that. But the idea is to do some kind of integration by parts, and part of what you're going to be left with might cancel one bit of the integral, so you don't have to do the integration for the other one. So for this particular one, this is actually question 722 on a book that I have on indefinite integration that has tons and tons of integrals. So I don't remember how to do this. So I hope it works the first time on what I'm going to try here. And what I'm going to try here is I'm going to concentrate on integration by parts, just on this one. So, pardon me, as per usual, my usual cough, and we're going to integrate the one. So for the time being, we're going to leave this item untouched, and hopefully that might cancel somewhere along the line. So log of x, that's going to go to 1 over the log of x from this bit here times a 1 over x. And this, of course, will go back into x. Do your integration by parts the way you normally do them. So this is the product of that. So that comes out of the integration. So it's x log of x minus the integral of the product of this diagonal. The 1 over x and the x will cancel. So we got 1 over the log of x dx, and I got a feeling this will work this particular way. Don't forget, this integration by parts is just for this item here, and of course we still have this particular quantity which we hope somehow it will cancel with what we're going to do on this particular one. So let's do integration by parts again, but for this particular quantity here. So the best way to mark this is if I use my orange pen. This is this integration by parts, and let's say we use a green pen, and for this item here we're going to have this integration by parts, and I just hope somehow this item might cancel. So we're going to differentiate the 1 over the log of x, and again we're going to integrate to 1. That's log of x all to the power of minus 1. So it's going to go minus 1 over the log of x all squared times the differential of the log, which is a 1 over x, and the 1 will come back into x, and again nicely this will cancel this 1 over x and the x, and I'm getting the right quantity here. The question is to make sure that the signs are all good and they do work. So with a bit of luck, this will just clear out on the next line. So that's that being copied, minus, now I'm going to use a bracket, and I'm going to write there the integration by parts. So it's going to be x over the log of x, the product of this column, minus the integral of the product of this diagonal. So it's minus is going to go plus. The 1 over x will cancel the x, and we got the 1 over the log of x all squared. It does work, doesn't it, because of dx, of course. And of course this is this item, and it's a minus, and of course we got a plus at the very end, and I think our integration is all done now. It will finish on the next line. You'll spare me and you won't let me. Actually, let me just copy it all out so we can actually see it. Log of x minus x over the log of x minus the integral of 1 over the log of x all squared plus, dx, plus, of course, the same integral, 1 over the log of x all squared dx minus and a plus. These two quantities will cancel, and therefore the answer, I'll write it up here, is x times the log of x minus an x over the log of x plus a constant. I hope you follow this particular one. This is kind of like, I might do one more of this type of integrals where you have somehow integration by parts, but you don't actually complete it. Bits of the integrand actually cancels in the process, and usually you can actually get it with 2, but more often it will be 3 items in the integrand. Okay, I'm going to be signing out. I hope you enjoyed and follow this particular integral. I'll see you real soon. Bye for now.